Good morning or evening whenever you are watching this. Today we are going to explore Azure PostgreSQL Flexible Server and we'll dive deep into what feature we get while creating, which option we need to select for our own use case. So when we create the instance, we get many options and we need to factor in into our own, is it a dev or a production or does it need backups or high availability, and then initialize the creation. So let's get started. So whenever we start with the creation, we need to choose whether we want a single instance, that is a flexible server or a elastic cluster. So in a flexible server, we have one instance in which our database will run, but in elastic cluster, we can have many nodes in it. Now let's understand the difference between these two. Flexible server is a modern recommended default model. It provides automated patching, maintenance windows, then we have high availability options. Also, it allows you to scale compute and storage independently. And another one, flexible server scales vertically, meaning we have to increase the CPU and the memory of the resource to handle the load. This server does not scale horizontally. Whereas in Elastic Cluster, we can have multiple nodes with the cluster to handle the traffic and performance. Data can be sharded, partitioned across workers. Queries can be executed across multiple nodes so that our single instance does not get heavily utilized. And other we get is the horizontal scaling, which is better for the large distributed workloads. So the next question will be, when do we need to select a flexible server or Elastic Cluster? So flexible server we can use when we want a managed PostgreSQL with high availability and maintenance controls, and we are aware about the predictable load is going to be there on the database and we don't need distributed scaling. Whereas in Elastic Cluster we can use when our dataset is large and growing, workloads are parallel or analytical, which can be taken care only when we have the horizontal scaling. So these are all the factors we can choose whenever we are creating the instance. So the next thing is the authentication, who can log in into the database, right? So we get two options, which is PostgreSQL native authentication, which is a simple username and password combination. The next we have is Azure Entra ID authentication, which is a centralized identity store for Azure. We get features like MFA support and best for whenever we do not want to manage the user password, rotations or expired passwords. Also, we have the option to enable both at once, so we can utilize both PostgreSQL and Azure AD authentication as well. And the pro tip here will be, if you are already using the Azure Entra ID, it's good to enable the Entra ID authentication because it provides you zero trust security model with the easier compliance and audit trails. Now, another major component of the security plus to access the database is the networking. So we have two options when we create the instance. We have public internet or private cloud. So whenever we are starting with the instance creation, whether it's a POC or a dev test environment, we can enable the public access. It's easier to set up, controlled via firewall rules, good for POCs, proof of concepts and small apps. But whenever we are working in production environment, or mostly we do not want to keep it a public, we always want to keep our instance in a private access, and that we can do via VNet integration or private endpoint, right? So in that case, our instance can be accessed by any other Azure resource privately within our own internal network, and also the database can access other resources as well. So next we have is a high availability. High availability comes into picture whenever we want our instance, whether it's Azure platform maintenance or it's a outage in the data center. This option will help instance to be always be available. Whenever these kind of failures happen, our instance will be up and running dependent upon whether we have opted for a high availability. Now the option we get is a zone redundant high availability, meaning our instance will be deployed across multiple zones in a region. That way, even if one zone fails or outage happens, our instance will be available in a secondary zone. And the benefit we get is that we have the automatic failover. We do not have to make any application changes. It is going to be all managed by the Microsoft Azure. We can also choose for a geo high availability, meaning if an entire region goes down, our instance will be up and running in the secondary region, and that is mainly for the disaster recovery scenarios. But also the drawback here, our cost will also get increased, right? In no high availability, it's cheaper. We have a single point of failure. But if our database is very critical in the terms of the revenue as well, it's better to have a high availability design so that we can get protected against any outages. Next we have is backup. So high availability, as we discussed previously, helps us whenever there's an outage or a failure happens in the Microsoft side, right? But backups is there to protect you from any accidental deletion, corruption happens in our database, or we want to go back in time. That is when backups will help us. They are for human mistakes, accidental deletes, or bad deployments, data corruption. These all scenarios will help us in backups. Backups are taken care by Microsoft itself. We do not have to install any agent. It's automatically going to taken care by Microsoft. The only thing we have to specify is the retention period, like 7 to 35 days, how often we want our data to be backed up. And after that, we get a point in time restore, meaning we can restore to any second. So suppose any deletion or we want to go back to a previous state of instance, we can specify it. We want to go back to 10 p.m. backup and it's going to automatically restore into that time. Next, we have the compute and scaling. So at the end of the day, PostgreSQL behind the scenes is just running on the virtual machine's queues. Like whenever we say we want a B series or a D series or a E series, similarly it runs on those queues. So we have got a burstable, which is less costly and is suitable for dev test workloads, right? So then we have is a general purpose, which is suitable for the most workloads, balanced CPU memory, and then we have got is a memory optimized, and this is suitable for heavy analytics and large data sets. We get more memory per vScore for faster query performance, right? So according to our own use case, we can choose our SKU accordingly. And the burstable will going to be less costly. General purpose is a moderate cost, and memory optimized is the more costliest one. Next, we have the maintenance window. So after the instance is deployed, Microsoft has to do upgrades, maintenance on the instance. We can specify the window when we want Microsoft update needs to happen, and the Microsoft will schedule the upgrades at that particular downtime. Next, we have is a monitoring and insight. So every resource, whenever we deploy, needs monitoring, especially for production, so that in case something happens, like a high CPU or memory utilization, that will cause the bottlenecks or resource constraint. Monitoring will help us to proactively monitor resources and take actions before the actual downtime happens. So in the monitoring and insights, we have got various options. We can see in the instance under monitor. We have query performance insights. We can check for CPU memory storage metrics, slow query tracking, and index recommendation. So next is mental model, and this will help us in finalizing what options we should choose whenever we are creating the instance, right? So the first will be the server type, flexible server or cluster. Flexible server will be there when we know how much the load is going to be there on the server and it's not going to grow frequently and it can be managed efficiently in a flexible server. We'll choose flexible server. Or if our workloads are more into analyticals and is going to require more performance, the cluster is the way to go. Next we have is authentication. Authentication we have is the standard PostgreSQL authentication, and another one is Entra ID. If Entra ID already exists, we should use it because it provides more security and the audit trails as well. Under networking, we should think like, should this ever be public? If app is a VNet, our database should be too, right? And then is high availability. So if an instance goes down, right, how much downtime can I afford? If it's a revenue critical, enable high availability. And in the backups, how far back might I need to go? 7 days minimum, 35 days. A recommendation for dev test, it's fine to go with 7 days, 10 days, but for a production, we may want to go more. Then we have a scaling. So we always have to check the metrics, like what CPU memory our resource is utilizing. If it's underutilized, we may have to downsize the resource, or if it's heavily utilized, we may want increase the size so that our resource is not under constraint and is working efficiently. Then we have to think of a maintenance. We have to specify a particular time duration and during which our instance can be upgraded or maintenance activity can happen. Next we have is a monitoring. Monitoring is very important after the instance is deployed and is working normally. For productions, we need to have the monitoring so that in case if our resource is heavily utilized, we get alerts proactively and we can take action before any outage happens. And the most important and the final is reservation. Under reservation, we have the option of saving up to 40 to 60% compared to pay-as-you-go model. So if we go with a 1 year, we get 40%, and under 3 years, we get 60% cost reductions compared to pay-as-you-go. And for this, we have to determine if our resource is going to be there for a 1 year or 3 year duration, and then we can opt accordingly. So this was all to understand before actually creating the instance, and now let's go into the portal and let's start the creation of the instance. So in the portal, we'll search for Azure PostgreSQL Flexible Server. We'll click on Create. And now the first thing we can choose is the subscription. I'll click on Cloud Demo and the resource group. I'll create new Postgre, and then the server name, demo instance, and the region will choose Central India. And the version we can choose from here, whether we want the latest or others. We can choose 18, 17, 16 according to our use case. Then is the workload type. We can choose the dev test, or the second we have is the production. The dev test, as we discussed, is the B series, which is burstable SKU, B2 series. And to get more into detail of this, we'll click on configure server. Now, as we discussed earlier, we have two options when we create a cluster. We have a server, which is our standard flexible server, and the second we have is elastic cluster, right? So that is what we discussed earlier. The flexible server, if we know our workload can be efficiently handled in this flexible server model, we'll choose that. Or if our workloads are more into the analyticals or high processing, it can go under elastic cluster to handle that workload type, which provides the horizontal scaling as well. So you can see here we have the node count. We can go from 1, 2, 3 to 20. So this is the power we get from the elastic cluster. But in the server model, we can go only vertically. We can just increase the SKU size so that it can handle the load, right? We choose the flexible server model. We have the compute tier burstable. So if you see, we get a B2S, which is 71. Similarly, we go to general purpose, which is going to be a D series, and it's more costly compared to burstable, right? And the memory is going to be more costly, which is our $103, right? So to select the compute size, we can go in here like standard D2DSV5. For this testing, I'll choose burstable B2S. And the next thing which you can see is we have the storage type, choosing automatically premium SSD. We do not have the option to use the standard STD or SSD. We get only two options, which is premium SSD and premium SSD V2. Next we have is a storage size, so we can opt for how much size we need. I'll stick with 32 gigabytes. And the performance tier, if you want more performance, because in premium SSD we can define our own IOPS, so we can choose according to our own use case. I'll go with 120. Next is storage auto grow. So in case if the storage, which is 32 gigabyte, is fully utilized, we can select this option. Even after 32 gigabytes, it's going to get increased without any manual intervention. But these sizes can only grow up to the point. Have to carefully check the storage or get a alert set up so that we get notified. Next we have is a business critical high availability, right, which we discussed earlier. So if I select on enabled, it will automatically create similar instance of and will replicate all our data to the secondary zone instance. So the instance cost will get increased. So we are getting the $369 per month because of high availability, right? And this cost is because it's going to create a similar instance on the other zone of that region. Next we have is a backup. We can select up to 35 days from 7 days. Next we have is geo redundancy. So it will help us in for a regional outage or disaster. So we can select this to get this feature. Next I'll click on save, and when we'll scroll down, we can see we have the authentication method. We have PostgreSQL authentication, which is a native feature of Postgre. Then we have is a Microsoft Entra authentication. Then we have is a PostgreSQL and Microsoft Entra authentication, right? So we can have both of them if we want. So for Microsoft Entra, we need to set an admin who is going to be the administrator of this database. So I can select my user, and now this user will be the administrator of this particular instance. And also we can specify the administrator login, which is going to be go to next networking. And in networking we have two options, which is public access and private access. So when we choose public access, we have the option to allow public access to this resource through the internet using a public IP. So any users can access this database publicly if the user has their public IP whitelisted on the firewall rules. So in this case, if I whitelist my IP, which is this particular one, I'll click on add current IP address. And if I create the instance with this feature, I'll be able to log into the server publicly. Next we have is a private endpoint. So now if we disable this, the firewall rules are also disabled because the internet access has been disabled and the only private endpoint access can be there. So we can create a private endpoint if you want to access the instance privately. Other option is the VNet integration. So when we opt this option, we'll need a virtual network and a dedicated subnet, meaning that subnet should not contain any other resource and the delegation is automatically done. So in this case, I'll not go with this particular feature. I'll stick to public access and then show you how I can access and I'll whitelist my IP and next I'll go to next security. In the security, we have two options, which is a service managed key and the customer managed key. In the service managed key for the encryption of our data is automatically taken care by Azure. We do not have to do anything. Our data is kept encrypted in the database with the key. And in the customer managed key, we have to provide our own key for the encryption and decryption of the data. And we can put that in the key vault as well. I'll stick with the service managed key, next tag, and then review and create. At the right side, you can see we have the estimated cost also, which is compute $365 and the storage cost, and this is how much we are going to get billed. There can be a networking cost also, but that cost will come after the instance traffic starts. So let's go to Azure pricing calculator and see how much cost we can reduce with the reservation. So I'll search for pricing calculator and then PostgreSQL. I'll choose the region Central India. That is what we have for our instance. And Central India, and the instance size is D4DSV5. We have a flexible server and the instance size is, so D series comes in general purpose, so we'll keep this for D4DSV5. This is our instance. And if we go for pay as you go, we have a $365 cost for the compute, which is what we are seeing here as well, right? Now, if our requirement here is to have the instance for 1 year or 3 year, depending upon our own use case, we can decrease our cost from 40 to 60%, which we can see here. If we select for reservation for 1 year, we get from 365 to $220, and 3 years we'll get savings more, and that is 146, which is a huge discount compared to pay-as-you-go model. And any resource which we create, if we have the option, we should definitely opt for reservation so that we can get this discount. Now let's go to the portal and then check once if everything is correct, and after we have finalized, let's click on create. So after 10 to 15 minutes it got created. Let's go to resource. We'll see various options we have on the left side. So we have the option to change the compute and storage. And the one thing which we discussed in the presentation, so we can schedule something, a custom schedule, and specify at what time of duration we want our instance to get upgraded like this. And it will automatically start any updates at that particular point of time. And it says that it is a 1 hour window and we can save it. Next, we have the alerts here. We can see the metrics and the logs or the workbooks to see the visual representation of the performance or any other queries, right? And like in enhanced metrics, we can see activity, database, auto vacuum, replication, and all those details. And now let's try to connect. Instead of Microsoft Entra, we'll choose PostgreSQL, and we can see the various options we can use to connect. To access the database, I'll paste a command to install the PostgreSQL extension. Now let's try to run the command psql, and it's running, right? So we'll try to access it via the CLI. We'll copy this command, go to terminal, then run this, put up the password, and you can see we are inside the database. So this was process how to access it via PostgreSQL, and whenever we're trying to connect via Microsoft Entra, we'll select the authentication method Entra, and then we'll copy this command and change the user to my user, right? And then use the next command to log in, which is this and again change the user to login. And you can see we are logged in, right? So this is how we can log in with Microsoft Entra ID and the native PostgreSQL authentication. And one important thing while we are connecting and we are using the Entra ID authentication via private access, which is VNet integration, we have to whitelist in the firewall following endpoints so that the request is not getting blocked. So I'll attach the link to this document in the chat. So you need to have these rules so that the access via Entra ID works. And this was the end of the session, how we create the PostgreSQL Flexible server, see all the features we get while the creation. The next video is going to be about how do we monitor the instance, the important baseline metrics like the CPU, memory, storage, and how do we set up the alert. So again, give a like, subscribe if you like this video, and see you in the next one.